Okay, this video is for Algebra 2, Unit 3, Lesson number 4. And this is on how we graph quadratic equations and inequalities. Now, this quadratic here does not mean 4. Quadratic is when we have x squared, and squared is the highest exponent. So we're leaving our equation with an x squared term. So that's what quadratic means. We have an x squared. I know a lot of students really want it to mean there's 4 of something, but there's not. That's not what it means in math. Now, we like to write our quadratic functions or equations in what's called standard form. It's like the normal or standard way to write the equation. It's the arrangement of all the terms. And that standard form of the quadratic equation is y equals, or you could say, f of x. Either way, I'm happy. Ax squared plus bx plus c. Now, we need to keep in mind here that a, b, and c represent numbers, like x squared and x stay that way in the equation. What do these represent? You might want to make a note that a is the number in front of x squared. That's what a means. A is the number in front of x squared. Okay. B is the number or coefficient, we could say. Sometimes I just like to just use real simple terms, is a number in front of just regular x. And c is the constant, which is just the regular number, okay? That's what a, b, and c mean. They are all just numbers, okay? So keep that in mind as we're working through all of this. Now, quadratic, whenever you have x squared, and x squared is like the highest exponent, and then we work our way down from there, we get a U-shaped curve called a parabola. Okay, it's not parabola, it's parabola. Now, what is a parabola? Let's talk about that as we move over here. Okay, we have two different functions given here. We have f of x equals x squared plus 2x minus 5, and then f of x equals negative x squared plus 3x plus 7. Now it says you could use your graphing calculator to sketch the function so that you wouldn't have to plot all the points. Because I can't show that at this point, I'll just give a rough sketch. In blue over here, the x squared plus 2x minus 5, that would be a parabola, okay, similar to this. A parabola makes a U-shaped graph, okay? And our green, negative x squared plus 3x minus 7, would actually be curved going the other way, more like a rainbow with the arrows pointing down, something similar to that. Now let's talk about it. If I said a is the number in front of x squared, well, let's talk about what that would represent. On my blue one, x squared plus 2x minus 5, a would be the number in front of x squared. Now notice I don't have a number in front of x squared, so for this equation over here, we're saying that our a value is equal to positive 1. So we're saying down here, if a is positive, then the parabola will open up. So opening up means your arrows end going up. Okay, our arrows are going up. Now, if our a value is negative, okay, if you have a negative number at the very beginning of this equation, a negative number in front of x squared, just in case they're out of the right order. Okay, here we have a is equal to negative 1. So down here it's saying if a is negative, then the parabola will open down like this. The arrows are going down. Okay, so arrows down means it goes down. Now, we kind of discussed this in Algebra 1 as well, and if you had me, I like to have little silly reminders. On my blue parabola, I had a equals 1, and that's because our a value is positive, and I said positive people are happy. Positive people smile, so you could kind of think of this as like a smiling, happy person right here. Okay, now on my green parabola, I would have told you that because there's a negative sign in front of x squared, our a value being negative 1, means that negative people are really unhappy. So if we like made this a face, this would be the green frowny face. So negative people frown, so that's why our arrows are going down, frown and down. That even rhymes. Okay, so that might be a little silly way to remind it. Positive people are happy, they smile, so our parabola looks like a smile. Negative parabolas open down like a frown. Okay, now let's talk more about this. We have every parabola has something called an axis of symmetry. Okay, so we all know what symmetry is. Symmetry is the point that we are, symmetry, we could like fold it over a certain line and our two sides would match up. And we did that with our absolute value functions, and our v's were symmetrical as well. So I know that we all know what symmetry is. But every parabola has a vertical line that divides the parabola into two equal parts called the axis of symmetry. So it's really important to find that axis of symmetry because our middle point, our vertex, is always on that axis of symmetry. We can find our axis of symmetry with a formula. That formula would be x is equal to negative b, okay, again, that number in front of x, divided by 2 times the a value. And that's why it's really important for us also to know what our a, b, and c values are, because we have to plug them into lots of different formulas starting with this lesson. Now the turning point of a parabola, okay, our turning point is called the vertex. Again, our absolute value v's had a vertex as well. So on my blue parabola, my vertex would be right here, and notice it's where my axis of symmetry is passing through. The vertex is on the axis of symmetry. That dotted line would be my axis of symmetry. Now, when our vertex is a lowest point, our vertex is called a minimum. Okay, that makes sense because look here at my blue parabola. Okay, that's the vertex right there, and it's the lowest point. Okay, we get no lower than that. It's my minimum. As we move from like left to right here, we are going down until we get to the vertex, and then we turn and start going up. That's why the vertex is called a turning point. Now, it says here when the vertex is the highest point, it's called a maximum. So if you're looking here at my green parabola, okay, we could cut it in half with our axis of symmetry, and we would have our vertex at the highest point. Going left to right, we are going up until we get to the vertex, and then at the vertex we turn and start going down. Okay, so when our vertex, for a negative or a downward going parabola, that is our maximum. Okay, so I feel like that's pretty straightforward and easy to see, and we've labeled all those values. Now on examples 1 through 4, we are going to be given 4 different quadratic equations. They all make some type of parabola if we were to sketch them out, but we're not supposed to do that yet. But what we're hoping to do is just by looking at the equation, we want to determine whether each function has a minimum or a maximum value, a highest or a lowest point, and then find the axis of symmetry and vertex just by using the equation and not having the picture of these quadratics yet. So this is where we need to get really good at being able to identify what the a, b, and c values are. So looking back at the top, I've written in what standard form is. I'm going to highlight that right here. We have y equals ax squared plus bx plus c. That's standard form. And again, a is a number in front of x squared. B is a number that's in front of x. C is our regular constant. There's no x's attached to it at all. So if we're on number 1, okay, my equation is just f of x equals 4x squared. So a is the number in front of x squared, so that's pretty easy. I have 4x squared, so a is the number 4. B is the number in front of x, but like notice there's nothing that comes after that. I don't have an x term. That makes the b value 0, and I don't have a regular number either, so that makes the c value 0. Okay, so that's what I know so far. Now, I can go here to answer whether I have a minimum or a maximum. So that's coming down to, is the number in front of x squared positive or negative? Okay, my a value is a positive 4. Okay, we have a positive leading coefficient, so positive. That means my parabola is happy. He's like a smile. His arrows are ending up. So doesn't that look like a smile? So that means my vertex is a minimum. It's at the lowest point. So you really have to picture what the parabola looks like and think, do you have a high vertex or a low vertex? I have a low vertex, so that's a minimum. Okay, next I want to find the axis of symmetry, which I've labeled as A of S down here, axis of symmetry. There's a formula to find that, and you guys really need to get to know that formula. That formula is x equals negative b divided by 2 times a. So we're going to fill that in. So we're saying x is equal to, okay, negative b. What did b equal? We labeled it over here. We said that's 0. So we could say negative 0, which is just 0. You could put just 0 over 2. And then times a is like right next to it underneath. A is 4. So this is 0 divided by 8. And whenever you have 0 on top, I notice some kids struggling with this. 0 out of 8 pieces means that you have a total of 0. So this makes our axis of symmetry x equals 0. The axis of symmetry is an equation, and you have to put this x equals. This is going to show up on, especially on one of our IXLs, and if you don't put the x equals, it marks you wrong, even if you get, like, for example, the 0 part right. So make sure you put x equals, and you'll need to have this on assessments as well. So it's a vertical line, okay, at 0 for x. Now, the cool thing is the vertex is always an x and a y value, right? That's our minimum, the point we are turning at, the point we are symmetric about. Whatever your axis of symmetry is, it's always the x value of your vertex. Pretty awesome. Notice it said x equals 0, and then x for the vertex is that same number, 0. So now we just need the y value of our vertex, which is found by plugging 0 in for x's in the equation. So we're going to say y is equal to 4x squared, right? So now we're replacing that x with the zeros. 4 times 0 squared equals 0. So when x is 0, y is 0. Our vertex is at 0, 0. Okay, that one's done. Moving on to number 2, we're going to apply all these same rules, but we have a different equation. We have y equals negative x squared plus 6. The first thing that I really do want you guys to do on your notes is label what a, b, and c is. Again, this is just a kind of a simple skill to have, but it's very important as well. So if a is the number in front of x squared, I just have a negative sign in front of x squared. That makes a negative 1. B is the number in front of x, so it's 6. C is like the last number, usually the constant, which would be 0 in this case because we don't have one. So we could think of this as saying like plus 0 if we would like. Now, I want to think, what does this parabola look like? Okay, what's a rough sketch, like in my mind? Now, notice I've got a negative sign in front of x squared. Whenever we have this negative sign in front of x squared, that means, okay, he's sad, he's negative. His arrows are going down like a frown because he's negative. So if our arrows are ending down, that means our vertex is a maximum. It's at the highest point. Okay, so we're at a maximum. Okay, next we need to find our axis of symmetry. So the axis of symmetry actually cuts through our vertex. It divides our parabola into 2 equal parts. Okay, again, it is always this formula that we are using. And that formula is x equals negative b over 2a. So again, that's why it was important to label our a and b values and c values up there. So to find the axis of symmetry, we have x equals negative b. We have to put a negative sign. That's part of the formula. Negative and then the b value, which is 6. Or you could think opposite of b as well. Over 2 times the a value, which is negative 1. So we have negative 6 over negative 2, which equals positive 3. Our negative signs cancel out here. So again, write the axis of symmetry as an equation. X equals positive 3. Okay, and the nice thing is after we found the axis of symmetry, that same number 3 is used as the x value in the vertex, so it's going first in the parentheses for the vertex. So the only thing that we are missing now is the y value of the vertex, which is found by plugging 3, that x value, back into the whole equation on the right side of the equal sign and plugging it in for all the x's. So again, if I have negative x squared plus 6x as my equation, I'm going to have negative parentheses positive 3 squared plus 6 times 3. Okay, type that into your calculator exactly like that if you want, or you could work it out by hand, but that would come out to positive 9. So we place that second in our ordered pairs parentheses. So the vertex is at 3, 9. That dot right there would have been 3, comma 9. Okay, on number 3, our function, our equation is f of x equals negative 2x squared plus 7x. Again, start by finding those a, b, and c values. A is the number in front of x squared. I'm going to keep saying that till it's drilled into your brains. So in front of x squared, we have negative 2. That's our a value. B is the number in front of x. So even though 7 comes next, it is not the coefficient of an x. So our b value here is 0. I don't have an x term. Okay, this can happen. Our c value is a constant. 7 is the constant, the regular number. So our c value is 7 here. Okay, so we labeled our a, b, and c. Now we need to think, what does this look like? Okay, so I'm looking back at the very first number in front of x squared. It is negative. Negative people are sad and they frown. So my arrows are going down. My arrows are going down, then my vertex is at the highest point. So I have a maximum. Okay, so that's what I know now. Now I need to find the axis of symmetry. What is the equation of this line that cuts my parabola into 2 equal parts? So the axis of symmetry is found by we're saying x is equal to negative b, or the opposite of b, divided by 2 times a. So again, I'm going to use these values that we labeled already on the left as for a, b, and c. So x is equal to negative and then 0 for b over 2 times negative 2. Now, as soon as I see that I've got 0 in the numerator, I can kind of stop. That means that everything in here equals 0. Again, to write the axis of symmetry, make sure you always start with x equals, and then we put 0. Okay, the vertex will be an ordered pair, an x and a y value. The x value from your axis of symmetry is the x value of the vertex. Okay, they go hand in hand. Our equation is negative 2x squared plus 7. We're plugging in 0 for the x's. So negative 2 parentheses 0 squared plus 7 equals 7. So our vertex, our turning point, is at 0, 7. That blue dot would have been 0, 7. Okay, so that's a lot that we can figure out from an equation without even graphing the real thing yet. Number 4. Okay, number 4, I have f of x equals x squared minus 8x plus 9. So I want us to start by labeling our a, b, and c values. A is a number in front of x squared. I don't have a number in front of x squared, so that means its coefficient is 1. B is a number in front of x. Pay attention to our signs. The b value is negative 8. C is the constant, so c is positive 9. Okay, so we've got those labeled. Next, we need to find our axis of symmetry. Okay, again, that's by saying x is equal to negative b over 2 times a. So we have x is equal to negative, and then our b value is negative 8. So my first negative sign is because of the formula of negative b, and then I put exactly what b is, and b was negative 8. So I got a double negative in the numerator. So we really have to be paying attention to our signs. This is over 2. Okay, there's always a 2 in the denominator times the value of a, which is 1. So negative negative 8 becomes positive 8 divided by 2, which equals 4. So our axis of symmetry is x equals 4. What is our vertex? We find our vertex by plugging this x value in for our x's. Hey, that's quite a connection there, right? We have x squared minus 8x plus 9. So we have 4 in parentheses squared minus 8 parentheses 4 plus 9, and that equals negative 7. So our vertex, the x value has to be 4. It matches the axis of symmetry value for x. Y is negative 7. Now looking at this, I kind of skipped over and I didn't ever answer if this was a minimum or a maximum, but I can still do that now. Okay, it doesn't really matter what order you do it in. That comes down to which way my parabola opens. So I am actually going to check what my first value is. What's the number in front of x squared? Is it positive or negative? Okay, A is 1, so it's positive 1. Positive people are happy. Happy people smile. Okay, so that's what the type of parabola it would be. If it's happy, then we have a minimum value. We have a lowest point for our vertex, which I now know is 4, -7. My axis of symmetry would be that line that cuts it right there. So this was a minimum. Okay, again, we'll keep using all of this, and now we're going to start graphing our quadratic equations. Now, when it comes to graphing our quadratic equations, our parabolas, we need to follow these 3 steps. The first thing we need to do is find the axis of symmetry and then the vertex. They really do go hand in hand. So if you remember, your vertex is a coordinate. We're going to have an x value and a y value. But the first part of the vertex is the axis of symmetry, which is found by doing x is equal to -b divided by 2a. That axis of symmetry, again, that is the x value of the vertex. Okay, so once you find the x value of a vertex, you always then go and plug that answer in for the x's in the equation and solve, and then that answer gives you the y value. So then you'll have an x and a y. Now, because the vertex is always a turning point about which the rest of the graph is symmetrical, we should always put the vertex in the middle row, just like we did when we found the vertex of our absolute value v's, okay? And then we're going to number up and down from the x's and then plug those values in for x and solve to get our coordinates, and then we're going to graph the whole thing. And remember, this is not like a V where it's pointy at the tip. This is rounded. It's curved more like a smile or a rainbow. Okay, so let's apply this as we start graphing. Okay, our first equation that we get to graph on number 5 is f of x equals -3x squared. Okay, so I like to start by labeling what a, b, and c are because we use especially our a, b values a lot. Again, a is the number in front of x squared. That makes a -3 for this equation because it was -3x squared. B is the number in front of x. Well, I don't have a b term or a c term actually because there's only one term altogether. So b and c here are zeros. So again, when it comes, look down here, we have our steps. First, we need to find our axis of symmetry and then plug that value in to get our vertex. So if you remember, our vertex we're going to place in the middle because everything else is symmetrical about that point. So if we're starting off by finding our axis of symmetry, we're using the formula x equals -b over 2a. So we have x is equal to -0 for x over 2 times -3. And I told you before, whenever you have 0 in the numerator, everything just equals 0. And that was our x value, so we're going to put it here in the middle of our x column. We need to find the y value of our vertex. So we plug it back, that 0 in for the x's of our equation. So we're going to get -3 times 0 squared, and that's going to equal 0. Okay, so our vertex is at 0, 0. Your vertex is not always at 0, 0, just happens to be this time. Now, let's real quick back up. Is this going to be a minimum or a maximum? Because this is a -3 in front of x squared, negative people frown, so my arrows are going down. I know that now that vertex I found is the highest point. Everything else should be going down. Now, how do I fill in the rest of this table? Just like I filled it in when I did my absolute value graphs. As I go up from the vertex, I like to put numbers to the left, so -1, -2, and -3. As I go down from 0 on the table, I'm putting numbers to the right, 1, 2, and +3. So now we're filling in our table. What we're doing again is putting these values in for x. So I'm going to start with -3 up here. So I'm plugging this all into, again, -3x squared. I have -3, and then in parentheses, I'm plugging in -3 squared, and that's going to equal -27. So I put that right next to it. Now that's not going to fit on my graph, but that's okay. I can still write it on my table. Okay, next I'm plugging in -2 for my x's. I have -3 times -2 squared. and that's going to equal, when I plug it in, negative 12 for y. Okay. Next we plug in negative 1 for x, so negative 3 times negative 1 squared. And really make sure that you are using parentheses when you plug these values in, or you're not going to get the right answers for y, which means your whole graph will be on and you're just off and you're just wasting your time. Don't waste your time. Use parentheses. Saves so much time in the end. We get negative 3. Now watch what happens. I'm going to go to the other side of my vertex and I'm plugging in 1 for x. So I have negative 3 times 1 squared, and that's going to also equal negative 3. Hey, I've seen that number before. Now we're going to plug in positive 2 for x. We have negative 3 times 2 squared, and that's going to equal negative 12. Next we plug in, so we have negative 12, and next we're plugging in positive 3. So negative 3 times 3 squared is negative 27. Okay, this happens with parabolas. Parabolas are symmetrical. It's a lot like it was with our absolute value graphs. Notice that we have our vertex. It's the only point for y where the values do not repeat. So that's kind of how you identify your vertex, especially if you're using your graphing calculator when we get to that point. 0, that's the only y that will be that number, and then on either side of that we have identical numbers, negative 3. On either side of those two numbers we have matching numbers, negative 12, and either side of that, negative 27's match. We have symmetry. Now, why is that so awesome? Other than it makes this really cool parabola, is that it helps you take a shortcut when you're filling in your tables. Those values on either side of your vertex should always repeat. Okay, now when it comes to graphing, we need to plot these points. We're at negative 1 and negative 3, and we're at positive 1 and negative 3. On either side of that, we're going down to negative 12, so that's going to be like a lot further down, about here and here. And again, make sure you make this like rounded and not pointy like our absolute value v's. Okay, now we do need to answer domain and range. Okay, we need to fill this in, domain and range. Let's not overlook that. Now domain, how are we spreading out from left to right? These are continuous graphs. There's no holes and no gaps. Essentially, what x values are we allowed to plug in? We don't have any restrictions. We could plug in any value for x and we could get some kind of output. Okay, and if you looked at your pencil test from left to right, if we extended these arrows far enough, we would go from negative infinity to positive infinity. And when we have that situation, we have a domain of all real numbers. Okay, and I don't want the highlighter, I want the pen. So we're going to put our braces. We have all real numbers. Okay, and this is like when we're not dealing with like piecewise stuff, when we're just dealing with regular parabolas, our domain will always be all real numbers for Algebra 2. Okay, there are different types of parabolas here, but for this, it's kind of like the absolute value graphs. The domain is all real numbers. The range is found in a similar manner as well. We either have a minimum or a maximum. Find your vertex. Okay, it's at that point, is it going above that y value or below? Okay, this vertex, the y value is 0, and it's going down from there below. So just like before, we put our brace. We say this is all the y's such that y is less than or equal to that y value of the vertex, 0. And we're done. Okay, on number 6, we have the function f of x is equal to x squared minus 6x plus 11. I'm going to start by labeling my a, b, and c values. A is the number in front of x squared. I can't see a number, so I know that number would be 1. My coefficient, if it's not there, is 1 when I have that value there. B is the number in front of x, so we have negative 6. And c is my constant. That would be 11 from that equation. Now, what kind of parabola am I expecting? Am I expecting happy or sad? My x squared term is x squared is positive. Okay, positive people are happy. Happy people smile. So we should be expecting a parabola where the arrows end going up. Now, and I like to start by thinking that way, because what if I accidentally plug it into my calculator, I hit the wrong buttons and plug it in wrong, and my values are going down? Okay, that would help me know that I'm like making a mistake and I need to like check how I'm typing it into my calculator. Now we need to start, like always, by finding the vertex, the middle point of our table. It's the middle of our parabola, so it's our starting point. Our axis of symmetry is formula is how we start finding the x value of the vertex. And again, that is x equals negative b over 2a. So we have x equals, we have negative sign, and then our b value, which is negative 6. We've got that double negative again, over 2 times a, which is 1. Negative 6 is positive 6 divided by positive 2, which equals 3. 3 is the x value of our vertex. Okay, we don't have enough for a dot right now, so we need to plug this answer in for x's in the equation. Okay, that equation is x squared minus 6x plus 11, and we're plugging in 3. So parentheses 3 squared minus 6 times 3 plus 11. Type it into your calculator. No need to work it out by hand if you don't want to. That comes out to positive 2. Okay, so again, that's my vertex. 3 right of the origin, 1, 2, 3, and up 1, 2. Put your dot. Okay, now what points do I have to the left of 3? I have 2, 1, and 0. To the right of 3, I have 4, 5, and 6. And we will plug each of these in. Again, I showed you how to do this quickly on your graphing calculator, where you can just type it in the first time and then use your highlighting and your arrows to just change your x values. But that would look like, okay, we have 0 squared minus 6 times 0 plus 11, which equals 11. Okay. Now, we're going to go over how to shortcut this in a minute. Next, we plug in 1. So I have 1 squared minus 6 times 1 plus 11, which is equal to 6. Okay, so when x is 1, y is 6. Next, we're going to plug in 2. So 2 squared minus 6 times 2 plus 11, all of that equals 3. Okay, because I've done one side and I know that the other side is symmetrical, okay, my vertex was in the middle, so on either side of the vertex we have to have matching y values. So if that 2 was plugged in to get 3, when I plug in 4, I would get 3. On either side of that, the number should match up. So I should have 6 next. And on either side of that, I get matching values, 11 and 11. And you could still plug it in and check, but that's how parabolas work. They're symmetrical. Now let's graph these points. When x is 2, y is 3, and 3. And either side of that, we're going to 6. And either side of that, we're going to 11, which I cannot fit on here. So we'll just know that it's going up. Okay. Again, make sure that bottom is rounded and not pointy like a V. Okay, so there's my parabola. Let's finish up by answering our domain and our range down here. Our domain, how are we spreading from left to right? What x values are we allowed to plug in? We're allowed to plug in anything. So we have all real numbers. My range, find your vertex, okay? And then what y value is that? And again, that will be the y value from your vertex on your table here, right there, that number 2, okay? Number 2. And the arrows are going up, which always means use a greater than sign. So the way we write it, we say braces and then a y. So all the y's such that y is greater than or equal to the number 2. That was our lowest y value, and we're everything above that point. Okay, number 7, f of x equals 2x squared minus 8x plus 6. Okay, my a, b's, and c's. A is 2, it's the number in front of x squared. B is negative 8. C is 6. Okay, I'm going to start by finding the vertex, what goes in the middle of my table, and that's starting with the axis of symmetry. Following this formula, negative b over 2a, I put a negative sign because of that negative in front of b, and then I put the b value, which is negative 8. all over 2 times the a value, which is 2. Okay, simplifying this, I get positive 8 over 2 times 2, which is 4. 8 divided by 4 is 2. The x value of the vertex is positive 2. Now we're going to plug that 2 in to the original equation for all of the x's. So we have 2 parentheses 2 squared minus 8 times 2 plus 6. Type it in, and we get out negative 2 and that's our y value of our vertex. We have positive 2, negative 2. So if we're starting at the origin, we're going to go right 2 and then down 2 to put our dot. And again, am I expecting the arrows to go up or down? And that comes down to what was my a value, what was in front of x squared. It was positive. Okay, a is positive. Positive people, happy. Okay, so we got arrows going up. Okay, we need to fill in the rest of our table. So to the left of 2, we have 1, 0, and negative 1. To the right of 2, we have 3, 4, and 5. Okay, starting by plugging in negative 1, we have 2 parentheses negative 1 squared minus 8 times negative 1 plus 6, and we get 16. Okay, so when x is negative 1, y is 16. Next, we're going to plug in 0. Okay, so we have 2 times 0 squared minus 8 times 0 plus 6, which equals 6. So when x is 0, y is 6. Next, we plug in 1. So 2 times 1 squared minus 8 times 1 plus 6, and that's going to equal 0. Pretty cool. Okay, so when x is 1, y is 0. And again, we're going to have symmetry. That's what all parabolas have. So the next point has to repeat. Okay, either side of the y value for the vertex repeats. And then working our way outwards, my next point has to be 6. So these 2 points have to match. And on either side of that, they're matching. So this one will be 16. So plotting the rest of our points, I'm going to have 3 and 0 and 1 and 0. I feel like these lines are kind of hard to see, but we're right here. And then 4 and 1, 2, 3, 4, 5, 6, and 0 and 6. Okay, and my next points are at a y value of 16, which I can't get to, but it is fairly skinny or stretched, vertically stretched, this graph. So here we go. But my arrows are ending up just like I said that they should before. So there's my parabola. My quadratic is graphed, answering domain and range. Okay, I know that I do not have any limit on my x values. It will be all real numbers. What's my range? Okay, I find my vertex. Okay, what's that y value for my vertex? It is negative 2. And it's everything above negative 2. So we are going to use a greater than sign for that. So our range is all the y's such that y is greater than or equal to negative 2. Okay, number 8, we have f of x equals negative x squared plus 5. Okay, right now I'm looking at a is going to be equal to negative 1. Because that a value, a is negative. Okay, a is negative. People frown, so the arrows are going down. That's what I'm expecting this parabola to do when we sketch it out. Okay, my b value is the number in front of x. I do not have an x term, so my b value is 0. My constant is 5, the plain old number. Again, starting with the axis of symmetry, we need the values in the middle of the table because it's the middle of the parabola. So we start off by saying x is equal to negative. The b value is 0 over 2 times a, which is negative 1. Again, if my numerator is 0, the whole thing equals 0. So the x value of our vertex is 0. So next we need to find the y value for that coordinate. We're plugging 0 in for the x's in the negative x squared plus 5 equation. So we have negative 0 squared plus 5, which is just going to equal 5. Okay, so my vertex is at 0 and then 1, 2, 3, 4, 5. Okay. And again, I know that my arrows will end up going down because we had a negative leading coefficient. Okay, next I'm going to plug in my x values. To the left of 0, I have -1, -2, -3. To the right of 0, I have 1, 2, and +3. So plugging in -3 first, I get negative, and then -3 in the parentheses squared plus 5, and we get -4 for y. Okay. Then next I'm plugging in -2, so I have negative, then -2 in parentheses squared plus 5, which equals +1. Okay, next we'll plug in -1 for x, so negative, then -1 squared plus 5 equals +4. Okay, now I've met back up with the vertex, so I know that I have symmetry about that point. So this point has to be 4. The next point has to be 1, and my last point has to match up with the first point, which was -4. Okay, now graphing. Okay, we already have 0, 5 there. On either side of that, we're going down to 4. On either side of that, we're going down to 1 for y. And then we're at -4. 4. Notice they're along the same line. Okay, so that's all the points we need to graph. Connect your points. Okay, and we're done with the graph. Okay, domain and range. My domain, no limits there. We are all real numbers. Our fancy R. Our range, find the vertex. Okay, my vertex is here. What's that y value? It's 5. Okay, and everything is below 5, so we're going to use a less than or equal to sign. So we have y, all the y's such that y is less than or equal to +5. Okay, next I'm going to move on to our quadratic inequalities. And now an inequality means we're using those greater than or less than or greater than or equal to or less than or equal to signs. We're going to complete our table of value in the same exact way, and we're going to plot our points. So number 1, nothing changes. This is going to be similar to when we did our absolute value graphs. We're going to use a dashed line for just the less than and greater than symbols that do not have the or equal to bars, and a solid line for the less than or equal to or greater than or equal to bars. So that didn't change. For shading, we shade above the line for greater than or equal to. That was the same as absolute value. We shade below the line for less than or equal to symbols. So again, this is very, very similar to when we did absolute value graphs. So we will do a few of these next. So number 1, we have f of x is greater than x squared plus 2x minus 2. So I'm still going to label my a, my b, and my c values because we use them. A is 1, b is 2, c is -2. I still want to find the vertex first. I find the vertex by using my axis of symmetry formula, which is x is equal to -b over 2 times a. So we get x is equal to negative, and then b is 2 over 2 times 1. So we have -2 divided by +2, which equals -1. I put that in the middle of my x column for my vertex. To get the y value that's right next to it, I plug -1 for my x's. So I'm using x squared plus 2x minus 2, and we're plugging in -1. So parentheses, always use parentheses when you plug in your values. Squared plus 2 parentheses -1 minus 2. What does that equal? And that equals -3. So I'm going to write it on the side of -1. So that's where I know my vertex is at. 1 left of the origin and down 1, 2, 3. There's my dot. Now should I expect this parabola to open up or down? My a value was positive, so I should expect my arrows to be ending up. And happy. Okay, so let's fill in the table just like we have in the past as well. To the left of -1, I have -2, -3, and negative 4. To the right of negative 1, we have 0, 1, and 2. Okay, this is still going to have symmetry. Again, that part's not changing either. I'm plugging in negative 4 first, so I have parentheses negative 4 squared plus 2 times negative 4 minus 2, and that equals positive 6. So I'm going to write 6 right here. Next, I'm plugging in negative 3. So we have negative 3 squared plus 2 times negative 3 minus 2. And that's going to equal positive 1. So we put 1 next to the negative 3. Okay, next, we're plugging in negative 2. So we have negative 2 squared plus 2 times negative 3 minus 2. And that equals negative 2. And again, these are symmetrical. So on the opposite side of the vertex, I need negative 2, and then I need 1. Those two values have to match. And then I need positive 6 last. So for right now, we're just putting our dots. Let's see. So outside my vertex, we go to negative 2. And on either side of that, we're at positive 1. And on either side of that, we're at positive 6. Okay, now this is where I stop because I have to check my inequality sign. Okay, my inequality sign was this. That is just a regular old greater than sign. So remember, your sign always tells you two things. Is it a dotted or a solid line that connects your points? This is just greater than, no, or equal to, so this is dotted. So I'm going to just okay, make sure I can tell that it's not a solid line. Okay, and then the next thing it tells me is if I'm shading above or below my vertex. Greater than, okay, this is greater. This means shade above. That's where things are getting greater. So if you're not sure, here's my vertex. What's above my vertex? It's all inside of the parabola. So I'm just going to shade everything inside here. It's like a little cup holding everything. And that's it. That's the only extra step, so that one's done. Okay, number 2 for our inequalities. We have f of x is less than or equal to negative x squared plus 4x minus 1. Okay, now notice my leading term is negative. Okay, so I have a is negative 1. And because a is negative, I should expect my parabola to be opening down. Okay, what is my b value? My b value is positive 4, and my c value is negative 1. Okay, so we need that middle of our table happening first. What goes in the middle here? So we're using our axis of symmetry formula. So here we go. We have x equals negative, and then our b value is 4 over 2 times a, which is negative 1. So this is negative 4 divided by negative 2, which becomes positive 2. Okay, let's place that right there. Okay, this is just so much fun, guys. I hope you're having a blast. We're going to plug that in for our x's in the equation, negative x squared plus 4x minus 1. So I have negative sign and then parentheses plugging in positive 2 squared plus 4 times 2 minus 1. What does that equal? That equals 3. So my vertex is 2 for x, 3 for y. So 2 right and up 1, 2, 3. And then again, I'm expecting my arrows to go down from here. My value for y should be getting smaller as we progress. So on the left side of 2, we have 1, 0, and negative 1. On the right side, we have 3, 4, and 5. Okay, now we're going to start by plugging in negative 1. So we have negative sign, and then negative 1 squared plus 4 times negative 1 minus 1. And that equals negative 6. Okay, now if that top one's negative 6, so is the bottom one. We can do our symmetry now if we want. Okay, plugging in 0 next. We have negative, then 0 squared plus 4 times 0 minus 1, and we're going to get negative 1. So negative 1 goes here, and if that one's negative 1, so is the value for 4 because of symmetry. Okay, next we're plugging in positive 1. we have negative and then 1 squared plus 4 times 1 minus 1, which equals 2. So if the value for positive 1 is 2, so is the value for 3. Okay, look at the symmetry we have going on. Wonderful. So we already have our vertex plotted at 2, 3. When x is 1, y is 2. When x is 4, y is negative 1. And then on either side of that, we're going down to negative 6. Okay, and connect your points. But don't do that yet. Ooh, did you see how I almost forgot? Because we're dealing with an inequality. Ooh, look how fast I almost forgot. Don't do that. Okay, check your sign. My sign right here, okay, that's what I'm highlighting, was this sign. Okay, this is a less than or equal to sign. So it tells me two things. Because it has the or equal to bar, I do have a solid line. Ooh, so I really wasn't going to mess up. Maybe my subconscious memory remembered that. I bet it did. Because I wouldn't mess up like that, would I? Okay. Ooh, that line is terrible, but it does the job. The next thing it's going to tell me is where I shade. Okay, am I shading above or below the vertex? Because it's a less than, that means to shade below. Okay, shade below the vertex. So here's my vertex. I'm shading below everything underneath there. Okay, color it in, and we're done. Okay, number 3, we have f of x is greater than or equal to negative 3x squared plus 18x minus 22. Okay, labeling A, B, and C. A is negative 3 because it's the number in front of x squared always. Because it's that first value is negative. Okay, A is neg. That means negative people frown. My arrows are going down. B is positive 18 and C is negative 22. Again, I'm not changing any of my steps ever. That's one of the things I love about algebra. It's very procedural. Okay, our steps don't change. We're going to find our x value first. We have negative and then B, so negative 18 over 2 times A, which is negative 3. So this is negative 18 divided by negative 6, which equals positive 3. We're going to plug that 3 back into the original equation. So we have negative 3, then parentheses, positive 3 squared, plus 18 times 3 minus 22, and that's going to equal positive 5. Okay, now notice, okay, our vertex is 3, 5. I had it kind of highlighted in there, not quite in the middle. I had one space above, but I fixed it now, so we're all good. Okay, mistakes happen. Woohoo. So 3, 5 is our vertex. So we're going 1, 2, 3, and up 1, 2, 3, 4, 5 for our first dot. Okay, let's plot our points on either side of that value. Okay, that would be 2, 1, and 0, and 4, 5, and 6. Okay, let's start with plugging in 0 for x. We have negative 3 times 0 squared plus 18 times 0 minus 22, and we do get negative 22. Okay, up here, negative 22. And again, if that value is negative 22, so is our bottom one. Next, we're going to plug in positive 1 for x. So negative 3 times 1 squared plus 18 times 1 minus 22, and we get negative 7 for our y value. So next we put negative 7 here and here. Okay, we're going to move and plug in positive 2. So we have negative 3 times 2 squared plus 18 minus 22. And that comes out to equal positive 2. So we put positive 2 here and here. Okay, let's plot the points that we have. So we're going to, remember our arrows are going down. It's going because it's negative for our A value. So we are at, let's see, 4 and 2 and 2 and 2. Right here and right here. And then either side of that, it's really stretched out here, and we're at negative 7. Down here and here. Okay, now stop because we have an inequality. Okay, our inequality sign. Okay, my sign looks like this, so this is greater or equal to. Okay, so what two things is that telling me? That tells me that I can have a solid line because it was or equal to that bar right there. So we're going to have a solid line to connect our points. Okay, make sure again it's rounded. And then am I shading above or below the vertex? Greater than means to shade above. Okay, shade above the vertex. So if my vertex is here, I'm shading above it. And so above is kind of like everything around in this situation. Up here, but we're going everywhere. So we're not on the inside for this one because that's not above the vertex. All of this business is. Okay, so that one was a little bit different than what we've had before. That's what it should end up looking like. Okay, we will do one last example for our inequalities. So I have the function f of x is less than x squared plus 6. Okay, what is my a, b, and c values? A is a number in front of x squared. There is no number, but I'm smarter than that. I know the number is 1. Okay, b is a number in front of the regular x term. I don't have one, so b is 0. C is the constant, so it's 6. We want the middle of our table. We want that vertex. So we want right in here. We start by finding the x value of our vertex by doing the axis of symmetry formula. Negative b over 2a. So I have x is equal to negative 0 over 2 times 1. I've got 0 in the numerator, so I'm like, wow, I'm smarter than that. The x value of the vertex is 0. Now we're going to plug that back in to x squared plus 6x. Not 6x, just 6. Silly me. It's almost midnight, guys. So we have 0 squared plus 6 on a Friday night, by the way. But I love you guys, so it's okay. That equals positive 6. Okay, our vertex is at 0, 6 for x. So we're going to start at the origin and go up 1, 2, 3, 4, 5, 6. Put our first dot. Now we're expecting this to go up or down. My a value, a is positive. So positive people smile. And that means our arrows should be going up. Okay, so there's our vertex. On either side of our x's, we have negative 1, negative 2, negative 3, and then positive 1, 2, and 3. Let's plug in negative 3. So we have negative 3 in parentheses squared. Again, if you don't use parentheses, you're going to get things wrong. Plus 6, and we get 15. So we have a 15 here and here. I love symmetry. Next, plug in negative 2. So we have negative 2 in parentheses squared plus 6, and that equals 10. So we have 10 here and here. And last, we plug in negative 1. So negative 1 in parentheses squared plus 6 equals 7. So our 7 is here and here. Let's finish plotting these points. At negative 1, we are 7, and at positive 1, we are 7. And then at 2, we're 10, and we don't have 10. It's kind of going to be like up here, okay? So don't connect your points because these are inequalities. We're going to take a little pause. Okay, what is my inequalities telling me? Okay, what's it saying? This is my sign. That's a regular old less than sign. The two things it's telling me, because it's less than but not or equal to, that's telling me to connect these with a dotted line. Good deal. The second thing it's going to tell me is to shade above or below. Less than, the numbers that get less are smaller and they're always going down. So we're shading below the vertex. So below, here's my vertex shading below. Okay, everything on this side of the parabola. So let's get our shading on. That was not shading. Shade, there we go. So shading below is everything down here underneath the vertex. You know, this is how I spent my Friday night, but I love you guys. I don't even know if anyone will ever watch this video, but if you do, I hope you learned something. Good night.